Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts project at thunderbolts.info. New discoveries today are forcing planetary scientists to consider completely rewriting the history of the planet Mars. NASA scientists are expressing their amazement over the completely unexpected discovery of a mineral in a Martian crater. Within the Marias Pass region of Gale Crater, a Mars rover has discovered a mineral called Tridymite, which only forms at super hot temperatures. The scientists are now speculating that the mineral was formed by incredibly powerful Martian supervolcanoes. NASA planetary scientist Richard Morris says of the discovery, "It was the last mineral we expected to see. If this stands the test of time, it has a lot of implications for how Mars evolved. We may have to rethink a few things." The discovery of Tridymite on Mars is highly problematic for standard planetary science. Mars is not known to have the dynamic subsurface plates that are thought necessary to create volcanic activity. And the planet's average temperature today is quite cold compared to Earth, at minus 67 degrees Fahrenheit. Indeed, Martian Tridymite is such an apparent problem that the investigators are now trying to discover ways that the mineral can form at much less than superhot temperatures. The aforementioned Richard Morris states, "Mars is a different place. Processes are different there. There may be something weird going on that we just don't recognize yet. But another process besides volcanic activity may be responsible for having formed the Martian Tridymite. Tridymite is a crystalline form of quartz that forms under low pressures and extremely high temperatures. Let us consider the close relationship between Tridymite and another high-temperature silica called Perchlorate, which is a form of silica glass found in lightning strike features. In fact, Tridymite has been reported as a product of lightning. In the book The Data of Geochemistry, Tridymite has been reported as a product of lightning on a roofing slate. Let us also consider the presence of another type of mineral on Mars, known as perchlorate. A 2015 article discussed the potential health hazards of the chemical for future astronauts on Mars. Various forms of perchlorate are created either by electrochemical processes or electrolysis. It has also been discovered that lightning can produce perchlorate in the presence of chloride. Amazingly, perchlorates are 10,000 times more abundant on Mars than sands or soils. The discovery of Tridymite on Mars is completely unexpected to NASA scientists, but it does not seem surprising to proponents of the electric universe. It is the position of the chief principles of the Thunderbolts project that the entire surface of Mars and other planets in the inner solar system were dramatically scarred by interplanetary lightning bolts in a period of planetary instability. Many previous presentations on this channel, including the feature-length documentary film The Lightning-Scarred Planet Mars, have outlined the evidence that high-energy electrical discharges have reconfigured the Martian surface. If these events did occur, we should expect the discovery of minerals on Mars that form in lightning and only at superhot temperatures. In the electric universe theory, the electrical scarring of planetary bodies excavated enormous volumes of material, which formed our solar system's comets, meteoroids, and asteroids. In recent years, comet scientists have been stunned to discover complex minerals that only form under extreme heat. NASA's Stardust mission to the comet Wild 2 did not reveal the abundance of interstellar dust expected to compose the comet nucleus. Rather, mineral inclusions range from anorthite, which is made of calcium, sodium, aluminum, and silicate, to diopside, made of calcium, magnesium, and silicate. Formations of such minerals require temperatures in the range of thousands of degrees. At the time, NASA curator Michael Zelensky said, "That's a big surprise. People thought comets would just be cold stuff that formed out where things are very cold. It was kind of a shock to not just find one, but several of these, which implies they are pretty common in the comet." The surprisingly complex minerals found in meteorites have also left geologists searching for answers. Glassy beads and stony meteorites called chondrules are especially puzzling, since the theory of meteorite origins in a primordial dust cloud did not allow for the extreme heating and sudden cooling required for the chondrules' formation. In 2013, a scientific study suggested a surprising conclusion, that lightning within a theoretical protoplanetary disk could explain the mystery. A Space.com report on the study stated, rocks melted in the early solar system after electrical currents spiked through the cloud of dust circling around the young sun. Unfortunately, despite these consistently surprising discoveries, planetary science has yet to seriously reconsider the story of our solar system's history. But the burgeoning field of electric universe geology is already opening new pathways of discovery. For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.